Hi and welcome to integration by parts. Integration by parts is used to integrate the product of two functions, especially where we've tried u substitution and that doesn't work. There is no product rule in integration, but the integration by parts formula actually comes from the product rule. So if we have the product rule from differentiation, which says that now we can integrate integral of f of g plus the integral of g of f. And then from this we can take out f of g equals the integral of and then integration by parts formula then becomes the integral of f g dash dx equals f g minus integral of f g dx. In this, u equals f of x, du equals f prime of x dx, v equals g of x, and dv equals g of x dx. So when we substitute back with our u's and dv's, we get the integral of u dv equals uv minus the integral of v du. And that is our integration by parts formula. Integration by parts, so if we have the integral of x e to the 6x dx we need to find out, for the formula, we need to find a u, a du, a v, and a dv. When we do our substitution, usually we try to find a u which when we differentiate it becomes more simple. So in this case, if we choose our u to be x, our du becomes dx, or 1 dx. Our dv, so this is our u, and the rest becomes dv. Our dv becomes e to the 6x, and then our v is the integral of e to the 6x, which is e to the 6x over 6, or 1/6 e to the 6x. When we then use our formula, which is integral of u dv equals uv minus integral of b du, here we get equals uv becomes u times v, which is x over 6 e to the 6x minus the integral of v du. So our v was again 1/6 e to the 6x, and then our du was dx. Then when we tidy this up, we get x over 6 e to the 6x minus, so the integral of 1/6 e to the 6x, we already have 1/6 e to the 6x, so this becomes 1/6 e to the 6x plus c, or x over 6 e to 6x minus 1 over 36 e to the 6x plus c. And that is our answer. Another way of doing this would be in a tabular form. So if we have a table, in this part we're going to differentiate, and in this part we're going to integrate. This part is u, and this then would be dv. So what we do is, again, we choose our u and x, so we have x, and over here we have our dv, which is e to the 6x. Now we differentiate again, going down, so here it's 1 dx, or just 1, and here when we integrate, so we're integrating on this column, we get 1/6 e to the 6x. Now what we can do is we can stop here if we wish, and then we do a diagonal line across, and here we have a positive, and here we have a negative. And then what we do is we multiply across there, and we minus the integral of across here. So this would be the integral of x e to the 6x dx, then becomes x 1 over 6, so that's x over 6 e to the 6x minus the integral of 1 multiplied by 1/6 e to the 6x, which is the integral of 1/6 e to the 6x dx, and then we proceed as above. Another alternative, make it easier, is if we differentiate when we get to 0, and then we don't need to do this integration at all. So if we do that, let's follow it through. If we can get to 0, this becomes x e to the 6x. This is 1. This is 1 over 6 e to the 6x. This becomes 0. And this becomes 1 over 36 e to the 6x. Don't forget our plus, minus, plus. Okay. We start at plus, then we go alternate minus, plus, minus, plus until we get to the 0. Now we draw our diagonal lines across, and this becomes the integral of 0 times 1 over 36, which is 0. So we can forget about that. Now we write our formula, which equals x over 6 e to the 6x minus 1 over 36 e to the 6x plus c. And that is our answer. So as you can see, that is the same as that answer, and this is a far easier way of doing our integration by parts. So I think that's the one we're going to use for our problems. Okay, let's have a quick revision of integration of 1 over x, or x to the minus 1. So when we integrate 1 over x dx, we get the natural log of x plus c. So the integral of minus 5 over z dz becomes minus 5 integral of 1 over z plus dz, and this is then when we integrate minus 5 natural log of z, absolute value of z plus c. Integral of 1 over 7y dy. This is, bring the constant outside, 1/7 integral of 1 over y dy, and this equals 1 over 7 natural log y, absolute value of y plus c. Integration of e to the x. So if we integrate e to the x dx, we get e to the x plus c. Integrating e to the ax dx, we get 1 over a e to the ax plus c, and then if we integrate a constant b e to the ax, we get b over a e to the ax plus c. So for example, integral of e to the 2x dx equals, we can actually, if you don't remember this, we can actually do this by u sub, that u equals 2x, du equals 2 dx, so dx equals du over 2. So this is then a half e to the u, and when we substitute the u back we get a half e to the 2x plus c. The integral of e to the 5x dx, 1/5 e to the 5x plus c, and integral of e to the minus 2x dx is minus a half e to the minus 2x plus c. So just a quick revision there of integration e to the x and 1 over x. Quick look at how to integrate 2x dx. We have to recall that e to the natural log of 2 is 2. So it's as if when e and natural log are next to each other they cancel out and we're left with the 2. So that's the rule when we're dealing with natural logarithms. So therefore the integral of 2x dx is the integral of e to the natural log of 2 all to the power x, which is e to the natural log of 2x dx. Let u equals natural log of 2x, du then becomes, because that's natural log of 2 is a constant, so becomes natural log of 2 dx. So therefore this becomes the integral e to the u du over the natural log of 2. So we take this 1 over natural log of 2 to the outside, and we have the integral of e to the u plus c. Now recall that e to the u is e to the natural log of 2x, and that equals, here we are, 2x. So this then becomes the integral of 2x is 1 over natural log of 2x, or 2 over natural log of 2 plus c. And that is our answer. Okay, let's quickly use that rule in an integration. So we have the integration of x, 5 to the power x. Let's do our little table here. I'm going to differentiate here, integrate there. Choose our u value as x. When we differentiate down we get dx. Here we have 5 to the power x. When we integrate down we get 5 to the power x over the natural log of 5. Do our line across, we're going to multiply that way, and then we're going to integrate here. This is a plus, this is a minus, so this becomes x 5 to the power x over natural log of 5 minus integral of 5 to the power x over natural log of 5 dx. So keep this the same, x 5 to the power x over natural log of 5 minus, bring the 1 over natural log of 5 to the outside, and we have the integral of 5 to the power x dx. These then remain the same, so that's x, 5 to the power x over natural log of 5 minus 1 over natural log of 5, and when we integrate 5x we get 5x natural log 5 plus c, and that is our answer. Integral of x plus 1 to the minus 3 over 2 dx. So if we make our table, we're going to differentiate here, we're going to integrate here, decide which is our u. So if we make u into x and differentiate, we get 1 or 1 dx. So our dv then becomes x plus 1 minus 3 over 2, and when we integrate this we get x plus 1 minus 3 over 2 plus 1 is minus a half, and that's over minus a half, which is minus 2 x plus 1 to the minus a half. Okay, so now we draw our line across, and this is the integral. This is a plus, this is a minus. So when we do the integration, x plus 1 minus 3 over 2 dx is equals x, and then we have the minus 2x, minus 2 rather, over x plus 1 to the half minus the integral of this, which is minus 2x plus 1 to the minus half dx. So this then becomes minus 2x over x plus 1 to the half minus a minus, minus a minus is a plus, the integral of x plus 1 to the half over half plus c, and we take the 2 to the outside. When we do the integration, this becomes minus 2x x plus 1 to the half plus 4 x plus 1 to the half plus c. Now the integral of e to the x minus x squared dx. So let's make our little table. Differentiating here, integrating down this column. So here we have e to the x minus x. This, when we differentiate, becomes e to the x minus 1, and here it becomes e to the x, and if we differentiate it carries on as e to the x. Here we're going to differentiate, integrate our dv, which is e to the x minus x dx. This then becomes e to the x minus x over 2, and if we integrate that again, that becomes e to the x minus x to the power 3 over 3, and obviously it continues ex, x to the power 4 over 4. It should be a half here. Okay, I think the best thing to do would be to stop here. We'll ignore this because it continues. Draw our line across, and our plus and our minus. Right. So then when we do our integration, if that equals I equals e to the x minus x, then we integrate across there. So we've still got to put this in, so that will be e to the x minus x squared over 2 minus the integral. So that's this minus here, minus the integral of e to the x minus 1 and then we have e to the x minus x squared over 2 dx. This remains like this. This integral we can FOIL out, so using our FOIL method, and we get minus the integral of ex times ex is e to the 2x minus ex times that, which is ex x squared over 2. Then we have minus times a minus, which is a plus x squared over 2, and then we have the ex So that's minus EX. So when we integrate this, we've got the plus, plus, minus. We can take each in turn, so this becomes minus the integral of e to the 2x minus the integral of ex x squared over 2 plus integral of x squared over 2 minus integral of ex dx. Now this integral we can do, this integral we need to use integration by parts again. This one we can do, this one we can do. So let's first of all sort this integral out. So we're going to do this one. So integral of ex x squared over 2 dx. Let's put our d and our I. So we're going to have u as x squared, and we're going to have our dv as e to the x dx. And when we do that, our du becomes 2x, becomes 2, becomes 0. When we integrate our ex's, we get ex, ex, ex. Do our arrows. This is a plus, a minus, a plus, and a minus. Okay, so this becomes x squared ex minus 2x ex plus 2ex plus c. Okay, so we've done this. Now we can integrate each in turn. So this then becomes a half e to the 2x. This is our thing here, so we'll do that towards the end. Our x squared over 2 becomes 1/6. X cubed, and our ex remains as ex. And I think that is it. Don't forget there's a half. This 2 is brought to the outside of the integral, it becomes a half. So there's a half there. So this then becomes I equals e to the x minus x, e to the x minus x squared over 2. Now we put this in, so this is minus a half e to x 1/6 x to the power 3 minus ex, and minus a half, and then what we had here, x squared ex minus 2x ex plus 2 e to the x plus c. We add the like terms. We get x cubed over 3 plus 2x e to the x plus e to the 2x 2 plus 2 ex plus c. This is an integration by parts, cyclical. This occurs when we have, say, an e to some power and a cos x or a sin x. So say we have the integral of e to the 2x cos x dx. So we make our little table on this side. Going to differentiate it down this column, integrate here. So we have e to the 2x. When we differentiate that, that becomes 2e to the 2x. When we differentiate that, that becomes 4e to the 2x. Now our dv is cos x. When we integrate that, we get sin x. When we integrate that, we get minus cos x. Now what we notice is that this isn't disappearing, and also this is going cos x sin x minus cos x, and it's going to remain like that. So what we'll do is we'll stop here, and we also notice that this e to the 2x cos x is from our original integrand. We're trying to get rid of it, but it's appeared here again. So let's write this out and see exactly what's happening. So this becomes e to the 2x sin x when we go across here, and then we go across here minus, let's go plus minus plus, a minus is a plus, 2e to the 2x cos x, and then plus, and the minus cos makes that a minus. Bring the 4 to the outside of the integral sign, e to the 2x cos x dx. And what we notice is this has appeared again here, so it looks like we've gone in a complete circle and we're going to have to do all this again. Little trick, what we do is this minus sign is going to save our bacon. So what we do is we take this across to the other side of the equal sign and we get 5. So this plus 4 is 5. Integral of e to the 2x cos x dx equals e to the 2x sin x plus 2 e to the 2x cos x. And then all we do is we divide this by 5, so what we wanted in the first place, e to the 2x cos x dx is 1/5 of this, and if we factor the e to the 2x out, we get e to the 2x 2 cos x plus sin x plus c.